there, space explorers. Welcome to another deep dive into some seriously cool space news.
Yeah, this is a good one.
This time we're heading to Barnard's star, our closest single star neighbor.
Right next door, cosmically speaking.
Astronomers have been on the hunt for planets around this star for over a century?
Yeah, it's been a bit of a white whale for them. Lots of false starts and debunked claims over the years.
So you can imagine the excitement when they finally hit the jackpot.
Oh, yeah. And not just one planet either. We're talking 4 new planets.
4! All right, so spilled beans, what are we dealing with here? Gas giants, super Earths?
Nope, even more interesting. These are sub-Earth planets, smaller than our own Earth.
Whoa, really? That's wild. So how did they spot these tiny planets? Were they just peering through some mega powerful telescope?
Not quite. It's a bit more intricate than that. They use this amazing instrument called MAROON-X.
MAROON-X.
Yeah, it's on the Gemini North telescope.
Yeah.
And this thing is so precise, it can pick up the tiniest wobbles in a star's movement.
Wobbles? I'm intrigued. Tell me more about these wobbles.
Okay, so picture a star, like a spinning top. If you give it a little nudge, it'll start to wobble.
Okay, I'm with you.
Well, planets, even little ones, exert a gravitational pull on their star, kind of like a cosmic tug of war.
And that causes the star to wobble.
Exactly. And a MAROON-X can detect those wobbles, which tell us there are planets tugging on the star.
So it's like a cosmic dance, the star and planets subtly influencing each other's movements. That's so cool.
It really is. And get this, one of these planets is the smallest ever found using this technique.
No way. So we're breaking records here.
Breaking records. It really shows how advanced our planet hunting tech is getting. This smallest planet, well, it suggests there could be a whole bunch of even tinier planets out there just waiting to be discovered.
Oh, wait, my mind is officially blown. So we have these 4 tiny planets dancing around Barnard's star. But what about the star itself? It's a red dwarf, right?
Right. Red dwarf stars are actually the most common type of star in the universe.
Really? More common than our sun?
Way more common. They're much smaller and cooler than our sun. Think like the size of Jupiter.
Wow. Okay. So that means they're habitable zones, the Goldilocks region where it's not too hot, not too cold, but just right for liquid water.
Exactly. Those habitable zones are much closer to the star.
So if these planets are so close to their star, does that mean they could be habitable?
But that's the big question.
Could there be life?
It's possible.
Hmm.
But in this case, these planets are probably a bit too toasty for liquid water. They complete their orbits, or their years, in just a few days, whizzing around the star.
Wow, their years are shorter than my work week. But even though these planets might not be teeming with little green aliens, I bet this discovery still tells us a lot about planets around other stars.
Right. Absolutely. Wow. Finding so many small, rocky planets around the most common type of star is a big deal. It really challenges our assumptions. You see, for a long time, we thought systems with big gas giants like ours were the norm. But this discovery suggests something different.
So our picture of the universe just got a whole lot more complex.
And a whole lot more interesting.
Okay, this is making my brain do somersaults. So if we're finding systems with multiple small planets, could some of those be in the habitable zone?
That's exactly the question scientists are eager to answer. And the more of these smaller planets we find, the more clues we gather about what makes a planet habitable in the first place.
So these planets may not be the best candidates for hosting life, but they're giving us a whole new perspective on how planetary systems form and what's possible out there.
Exactly. It's not just about finding new planets. It's about expanding our understanding of the universe and our place in it.
I love that. So to recap, we have 4 new planets around Barnard's star, all smaller than Earth, zipping around their star in super fast orbits and giving us a whole new understanding of what planetary systems can look like. Incredible.
It really is. And the most amazing part, we're only just scratching the surface of what's out there.
Okay, before we get too carried away with the endless possibilities, let's take a closer look at this amazing planet-finding technique that made all this possible. This radial velocity method, it sounds super complex.
It might sound complex, but the principle behind it is actually quite elegant. Imagine you're on a boat and you see a buoy bobbing up and down in the water. You can't see the waves directly, but the buoy's motion tells you they're there.
Ah, I see. So the star is like the buoy and the planets are like the waves causing it to wobble.
Exactly. And just like bigger waves cause the buoy to move more dramatically, larger planets cause more pronounced wobbles in their stars. That's how we can figure out the mass of these planets by measuring how much this star is wobbling.
That's such a cool analogy. It makes me think about all those sci-fi movies where spaceships detect gravitational anomalies. This is like real-life sci-fi happening right now.
It really is. And what's even more fascinating is that this technique allows us to find planets even though we can't see them directly. It's like a detective using footprints to track down a suspect.
So we've got this incredible detective work happening, uncovering hidden planets all over the galaxy. And this latest discovery around Barnard's star, it's really shaking up our understanding of planetary systems, right?
Absolutely. We used to think our solar system with its large gas giants in the outer regions was typical.
Yeah.
But as we find more and more exoplanets, we're realizing that systems like Barnard's star with multiple small rocky planets closer in might be much more common.
It's almost like our cosmic perspective is doing a complete 180. So if these smaller planets are more common, what are the chances of finding one that's, habitable?
The big question, isn't it? While these particular planets around Barnard's star are likely too hot for life as we know it, there could be countless other planets around other red dwarf stars that sit right in that sweet spot, the habitable zone.
Okay, let's talk about that. What makes a planet habitable anyway? Is it as simple as being the right distance from its star?
Well, it's definitely more complex than just distance. Think of it like baking a cake. You need the right ingredients in the right proportions, and you need to bake it at the right temperature for the right amount of time.
Okay, I'm following you. So what are the ingredients for a habitable planet?
Liquid water is essential, of course, but you also need the right kind of atmosphere, one that can trap heat, but also protect the surface from harmful radiation. And the planet needs the right chemical building blocks for life. Things like carbon, hydrogen, oxygen, and nitrogen.
It sounds like a delicate balancing act. So even if a planet is in the habitable zone, it doesn't necessarily mean it's going to be a welcoming paradise.
Exactly, and that's what makes the search for life beyond Earth so challenging, but also so incredibly exciting.
So let's say we find a planet around a red dwarf star that checks all the boxes, right temperature, right atmosphere, right ingredients. What would life be like on a planet like that? Would it be anything like Earth?
Not necessarily. Remember, red dwarf stars are much smaller and cooler than our sun. That means planets in their habitable zones would be much closer to their star, and they'd experience some pretty unique conditions.
Like what? Paint me a picture. What would it be like to stand on a planet like that?
Well, for one thing, these planets are often tidally locked to their star. Imagine our moon. We always see the same side because it's tidally locked to Earth.
So one side of the planet is always facing the star and the other side is in perpetual darkness. That sounds intense.
Exactly. It creates some extreme environments. The day side could be scorching hot, while the night side could be freezing cold, and that kind of temperature difference would lead to some pretty wild weather patterns.
Whoa. So maybe not the best place for a beach vacation. But could life still exist in those extreme conditions?
Life is surprisingly resilient and adaptable here on Earth. We found organisms that can survive in the most extreme environments imaginable, from boiling hot springs to the freezing depths of the ocean. So it's certainly possible that life could find a way to thrive on a tidally locked planet around a red dwarf star.
Okay, that's blowing my mind a little bit. So we might not find little green aliens on a planet like that, but there could be some seriously strange and wonderful life forms out there, right?
Absolutely, and that's what makes the search for extraterrestrial life so captivating. It's not just about finding another Earth. It's about discovering the incredible diversity of life that might exist out there in the universe.
This is all so fascinating. It makes me realize how much we still don't know about the universe.
We're only just beginning to explore the vast tapestry of planets and stars that make up our cosmos.
And speaking of exploring, let's go back to Barnard's star for a minute. I know we touched on this earlier, but it's incredible to think that astronomers have been searching for planets around this star for over a century.
It really is, and there have been several false alarms along the way, previous claims of planets that turned out to be, well, not planets.
So what makes this discovery different? Why are scientists so confident that these 4 planets are the real deal?
The difference is the technology. The instruments we're using today, like MAROON-X, are incredibly precise. They can detect the tiniest wobbles in the star's movement, which allows us to confirm the presence of these planets with a high degree of certainty.
So it's not just about seeing the planets themselves, it's about measuring their gravitational influence on their star, right?
Precisely. And the data from these instruments is so compelling that there's really no doubt that these planets exist.
It's amazing how far we've come in our ability to study the universe. So let's zoom in on these 4 planets around Barnard's star. We know they're small and rocky, but what else can you tell us about them?
Well, as we mentioned earlier, they all orbit incredibly close to their star, with orbital periods ranging from just a few days to a couple of weeks. And based on their masses and their proximity to the star, we believe they're likely very hot, with surface temperatures reaching hundreds or even thousands of degrees.
Wow, definitely not places you'd want to visit for a summer vacation. But what might the surfaces be like? Could there be volcanoes or canyons?
It's hard to say for sure without being able to directly observe their surfaces. But based on what we know about planetary geology, it's certainly possible they could be barren rocky worlds, or they might have molten surfaces. We just don't know yet.
Okay, so there's still a lot of mystery surrounding these planets, but that's part of what makes them so fascinating. Each new discovery opens up a whole new world of possibilities and challenges us to rethink our understanding of the universe.
Exactly, and that's what makes astronomy such an exciting field. It's a constant journey of exploration and discovery.
Speaking of exploration, remember that record-breaking tiny planet we talked about, the one that's the smallest ever detected using the radial velocity method?
Oh, absolutely. Barnard star E. It's truly remarkable.
I'm ready to dive deeper into that. Can we unpack what makes this discovery so groundbreaking and what it means for the future of planet hunting?
Let's do it. It really does open up a whole new realm of possibilities. It really is a game changer.
So this Barnard star E, it's really tiny, right?
Oh, yeah. Only about 20% the mass of Earth. It's barely a blip on the cosmic scale.
That's mind-boggling. How do you even detect something that small?
Well, it all comes down to gravity. Even a planet that small still has gravity, and that gravity tugs on its star, causing it to wobble ever so slightly.
I see. So it's still that same wobble technique. But how much are we talking about here?
I mean, we're talking incredibly subtle movements, like trying to see the width of a human hair from miles away.
Wow, that's some seriously impressive technology.
It is, and thanks to that precision, we can now find these minuscule planets. It really makes you wonder just how many more tiny planets are out there just waiting to be discovered.
Right, just hiding in plain sight, cosmically speaking.
Exactly. It's like we've discovered a whole new category of planets that we didn't even know existed before. And to find one around Barnard star, a star that's been studied so extensively, it's really remarkable.
It makes you think about all the assumptions we've made about planetary systems, right? I mean, we've got these gas giants in our solar system, Jupiter, Saturn, but maybe that's not the norm. Maybe these small rocky planets are much more prevalent.
That's a very real possibility. And if that's the case, it has huge implications for the search for life beyond Earth. I mean, the more small rocky planets we find, the greater the chances of finding one that's in the habitable zone, right? With conditions that could support life.
So this tiny planet, it's potentially a huge leap forward in the search for extraterrestrial life.
Absolutely.
But finding them is just the first step, right? What's next?
Well, now we need to learn more about them. Their atmospheres, compositions, their potential for hosting life.
So how do we do that? Can we see these planets directly, or are we still relying on those indirect methods like radial velocity?
Right now, we're still mostly relying on indirect methods, but telescopes are getting more powerful all the time. We're getting closer to being able to directly image some of these exoplanets, which would be incredible.
That would be amazing, being able to actually see what they look like.
It would revolutionize our understanding.
So looking ahead, what are you most excited about in the field of exoplanet research?
Honestly, what excites me the most is the unknown. The fact that we are constantly discovering new things that challenge our assumptions and push the boundaries of what we thought was possible. Every new discovery opens up a whole new set of questions and possibilities.
It's a never-ending adventure, and it makes you realize just how much we still don't know about the universe.
We're just scratching the surface.
Well, it's been an incredible journey today, learning about these 4 new planets around Barnard's star, and it really highlights how our understanding of planetary systems is constantly evolving.
It really does. And it's a reminder that the universe is full of surprises, full of wonder.
So to all our listeners out there, keep looking up at the stars, keep asking questions, and never stop exploring the wonders of the cosmos.
Who knows what incredible discoveries await us in the vast expanse of space?
This is host speaker name, signing off. Until next time.
Clear skies.